Example 11 says, given that cosine of t is equal to 2/3, where t is in the fourth quadrant, find tangent of t over 2. So let's draw our right triangle. We know that t is in quadrant 4, so that's going to put us here, and let's call this t, and we know that the cosine is 2 over 3, so that's going to give us a value of 2 here, and then the length of the hypotenuse is 3, and I'm going to call this a, and I'm going to solve a by using the Pythagorean Theorem. Nothing too exciting there, all stuff we've seen before. So we get a squared is equal to 9 minus 4, and if we take the square root of both sides, we get a is equal to the square root of 5. And because we're in the quadrant 4, we know that this is negative square root of 5. And we are not finding tangent of t, we are finding tangent of t over 2. And so I'm going to use the half angle formula that we found earlier. And so this is equal to 1 minus cosine of t over sine of t. And this is actually not the one that we derived. We derived this formula here, but I'm going to decide to use this one, and either one you use should give you the same answer. So let's go ahead and figure this out now. That's going to be 1 minus cosine of t, we already know, we got here, so that's 1 minus 2/3 over sine of t, which would be negative root 5 over 3. And 1 minus 2/3 gives us 1/3. If you want, you can find the common denominator and work that part out. And then I want to multiply by the reciprocal of this thing, so times negative 3 over the square root of 5. And the 3's will divide out, and that will leave me with negative 1 over the square root of 5. And I want to rationalize that, so I'm going to multiply this by the square root of 5 over the square root of 5. And that's going to result in negative square root of 5 over 5. And there is our answer for example 11. Example 12 wants us to find the exact value of cosine of 15 degrees. Now, let's remind ourselves really quickly the formula for the half angle identity for cosine. So cosine of u divided by 2 is equal to plus or minus the square root of 1 plus cosine of u over 2. Now, you might be asking yourself, how are we going to use that formula in this scenario? Well, we know the cosine value of 30 degrees, and 15 happens to be 30 divided by 2. So we can write cosine of 15 degrees as cosine of 30 degrees divided by 2. And then that's going to give us, based off the half angle identity, plus or minus the square root of 1 plus cosine of 30 degrees over 2. So we have the plus or minus in front, and I gave you the note earlier that you're going to have to decide which one to use based off where our angle is. And 15 degrees is in quadrant 1, and it looks, something like that. Here's 15 degrees, and we know that in quadrant 1, cosine is positive, and if you don't remember the mnemonic device, it's all students take calculus, and so this mnemonic device tells us which trigonometric functions are positive in which quadrants. So all of the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So I can go ahead and erase this and just put the plus sign, but we know that plus sign, if we erase that, that indicates that this is positive. So we can start moving forward from here. I have the square root of 1 plus cosine of 30 degrees is something we should have memorized based off the unit circle. And we know that cosine of 30 degrees is root 3 over 2. And then we're dividing that by 2 there. I'm going to go ahead now and find a common denominator. So this is equal to the square root of 2 over 2 plus root 3 over 2, all divided by 2. And then that's going to be the square root of 2 plus the square root of 3 over 2, all divided by 2. And if I multiply by the reciprocal, that's going to look like that. And we're going to get the square root of 2 plus the square root of 3 over 4. And I can rewrite that as the square root of 2 plus the square root of 3 over the square root of 4. And then finally, we get the square root of 2 plus the square root of 3 over 2, like that. And this is our final answer for example 12. Example 13 says, write sine of 2 times cosine inverse of x as an algebraic expression in terms of x. Now, remember this thing, cosine inverse of x, is just some angle theta. And so I'm going to make that substitution so that we can end up using the double angle identity. So if we make that substitution, we can really think of this as sine of 2 times theta. And now if I use the double angle identity, I have 2 times sine of theta times cosine of theta. And we know that the cosine of this angle theta is equal to x. And so that's going to help us think about the right triangle. So if I have some angle theta here, and we know the cosine value of that angle theta is x, then that tells us that this length will be x, and the length of the hypotenuse will be 1. And so now we can solve for the height of this triangle, this right triangle, using the Pythagorean theorem. So c squared plus x squared is equal to 1 squared. And then if we take the square root, we get the square root of 1 minus x squared. So I'm going to replace that here in my little diagram. And now we should be able to fill in these values here. So this is now equal to 2 times sine of theta is going to be opposite over hypotenuse. So this is the opposite value. This is our hypotenuse. This is our adjacent. And so we'll have the square root of 1 minus x squared over 1. But really, the over 1 part is unnecessary. And then we know that cosine of theta is x over 1. But again, the over 1 part is unnecessary. So I'll just write x. And I'm just going to reorder this so that it looks a little bit nicer. So we get sine of 2 times cosine inverse of x is equal to 2 times x times the square root of 1 minus x squared. And that concludes example 13.